For the better part of a century, it appeared as nothing more than a tiny speck of light in the vast darkness of the night sky. A distant, cold, and mysterious world sitting silently at the outer edge of our solar system, so far away that even the most powerful telescopes could only offer the vaguest hints of what it might be. This enigmatic object, for decades, held the distinction of being the ninth planet from the Sun. It was the last of the classical planets, discovered after all the others, a solitary wanderer among the icy reaches of the Kuiper Belt. Its name, Pluto, evoked both mystery and a sense of the unknown, a final frontier within our planetary family. But in 2006, the astronomical community made a decision that would ignite debate for years to come. In a controversial move, the International Astronomical Union redefined what it meant to be a planet. And just like that, Pluto was demoted. No longer a full-fledged planet, it was given the title of dwarf planet. A label that felt to many like a demotion, almost a slight against this distant world that had captured imaginations for so long. The uproar was immediate. Scientists, teachers, students, and space enthusiasts alike found themselves embroiled in passionate discussions about planetary definitions, classification systems, and whether Pluto truly deserved to be stripped of its planetary crown. But before that moment of demotion, before the controversy, before the headlines, Pluto had already been at the center of another extraordinary discovery. In 1978, something remarkable happened. A planetary scientist named James Christie, while examining old photographic plates of Pluto, noticed a small bulge in the planet's image that seemed to shift position over time. This was no photographic artifact. What Christie had found was Pluto's moon, a large natural satellite that would come to be known as Charon. But this was not your average moon. What made Charon stand out was its size in relation to Pluto. It was enormous, so massive, in fact, that the two objects don't behave like a traditional planet and moon system at all. Instead of one body orbiting the other, Pluto and Charon actually orbit a common center of gravity that lies outside of Pluto itself. This cosmic arrangement makes them more of a binary planet system than anything else, a pair of icy partners locked in an eternal dance through the frigid depths of space. Decades would pass before humanity would get a proper look at this extraordinary duo. Telescopes, even the Hubble Space Telescope launched in the 1990s, could only resolve them as blurry spheres. That changed dramatically on July 14, 2015. After a 9.5-year journey across the solar system, traveling over 4.8 billion kilometers, NASA's New Horizons spacecraft arrived at the Pluto system. It was moving at an astonishing velocity, nearly 58,000 kilometers per hour, and had just one chance to capture detailed images and data as it flew past. There would be no second opportunities, no turning back, no slowing down. This was a one-shot mission. As New Horizons approached its destination, anticipation on Earth reached a fever pitch. Scientists, engineers, and space lovers around the world waited breathlessly. Because Pluto and Charon were so distant, it took 4 hours and 25 minutes for a signal from the spacecraft to reach Earth. When it finally did, the images that came through changed everything. For the first time, Pluto appeared not as a blur, but as a richly detailed, astonishingly complex world. And following close behind came the first up-close images of Charon, a world no longer lost in Pluto's shadow, but standing alone in stark, rugged detail. In those moments, as the images arrived one after another, a transformation took place, not just in the way we saw Pluto and Charon, but in the way we understood the outer solar system as a whole. Here, at the edge of our planetary neighborhood, was a pair of worlds more fascinating and geologically diverse than almost anyone had predicted. Before this monumental flyby, the best images of Charon were little more than dots, tiny featureless patches of light barely distinguishable from Pluto itself. The first detection of Charon back in 1978 had come from subtle elongations of Pluto's image, hinting at the presence of a companion. It wasn't until much later that Hubble could begin to resolve the two objects separately, giving us a slightly clearer sense of their size and shape. But still, they were mysteries. Then came the moment when New Horizons sent back a crystal-clear image taken from about 74,000 kilometers away. And what we saw was jaw-dropping. Charon, it turned out, was a world carved by time, etched with the scars of geological change and painted by processes still not entirely understood. One of the most immediately striking features was the dark red stain at its north pole, a stark contrast to the pale, icy surface that covered most of the rest of the moon. This unusual coloration had never been seen on any other moon or planet in our solar system in quite this way. The feature was given the name Mordor Macula, a nod to the shadowy lands of Tolkien's fictional universe. But the real cause of the stain was even more intriguing. As it turns out, Pluto's atmosphere contains methane gas, and some of that methane is escaping into space. Because Charon orbits relatively close to Pluto, just 19,000 kilometers away, some of that methane ends up falling onto Charon's surface. Once there, it is exposed to solar radiation, which alters the methane molecules and transforms them into tholins, complex reddish organic compounds. Over time, these tholins build up, creating that dark red polar cap. It's a powerful visual symbol of the link between Pluto and Charon, as if Pluto, even as it loses mass to space, is reaching out and painting its companion with its own atmosphere. But Charon is far more than just a canvas for Pluto's escaping gases. Its surface tells a dramatic story of internal activity, upheaval, and transformation. One of the most breathtaking features is an enormous canyon system that stretches across Charon's equator. This colossal network of canyons spans more than 1,600 kilometers, so large that it likely wraps around much of the Moon's surface. In some places, these chasms plunge more than 9 kilometers deep, making them twice as deep as Earth's Grand Canyon and 4 times as long. What could create such staggering fractures? The most likely explanation is that Charon once had a subsurface ocean, a layer of slushy, partially liquid water hidden beneath its icy crust. Over time, as Charon's interior cooled, that ocean likely froze solid. Water expands as it freezes, and as this process occurred, it would have pushed outward against the crust, cracking it open and creating enormous tectonic faults. What we're seeing today, these vast cliffs, towering ridges, and deep valleys, is the aftermath of that internal freezing. Charon literally split itself open from the inside out. And yet, the story doesn't end there. Charon's surface offers a stark contrast between its two hemispheres. The northern regions are densely cratered, ancient and battered, marked by billions of years of impacts. But the southern hemisphere appears much smoother, almost as if it's been resurfaced. And that's exactly what scientists believe happened. This smoother terrain is thought to be the result of cryovolcanism, a process in which icy material, rather than molten rock, erupts from beneath the surface. At some point in Charon's history, cracks in the crust may have opened pathways for slushy water, ammonia, or other volatiles to ooze outward. These materials would have spread across the surface before refreezing, creating vast plains that appear fresh and uncratered when compared to the older terrain to the north. This suggests that Charon remained geologically active far longer than scientists had expected. Rather than being a frozen, dead world, it was alive with internal motion, at least for a time. Among the most peculiar and compelling discoveries on Charon are the features known as mountains and moats. Scattered across the southern hemisphere, these strange geological formations consist of massive blocky peaks that appear to be sitting in shallow depressions, as if they're floating in frozen lakes. One of the most prominent is Kubrick Mons, a rugged mountain rising nearly 4 kilometers high and encircled by a broad sunken trench. The formation's name is a tribute to filmmaker Stanley Kubrick, whose work in science fiction is legendary, but its geological origin remains a mystery. These mountain and moat structures may be remnants of ancient cryovolcanoes, where once active vents spewed icy slurries onto the surface. Over time, those icy flows would have solidified, leaving behind these towering mounds surrounded by subsided, collapsed terrain. They are unique in the solar system. No other moon or planet has shown anything quite like them. And there's more. Along Charon's canyon belt, we find evidence of truly colossal landslides, some of the largest ever observed anywhere in the solar system. Great sections of cliff face appear to have broken away and cascaded downward, creating long trails of debris that stretch for kilometers. These are not gentle processes. These landslides speak to a time when Charon's crust was still pliable, still capable of movement. When tectonic shifts and structural collapse could send enormous sheets of ice crashing down across the surface. The forces at work here were vast, and they left behind frozen signatures of chaos and change. Taken together, all of this paints a picture of Charon not as a quiet, passive satellite, but as a dynamic, evolving world. While Pluto dazzles with its heart-shaped nitrogen glaciers and blue atmospheric hazes, Charon tells a different story, one carved into the ice and rock of a moon that cracked, flowed, erupted, and collapsed over the course of billions of years. It lacks the atmospheric drama of its parent, but what it offers instead is geological grandeur on an astonishing scale. Even now, with all we've learned, questions remain. How long did Charon's subsurface ocean last? Could there still be pockets of warmth beneath the surface today? Might there be more to learn about how tholins form and spread? What else could we find if we returned for another look? One thing is certain. Charon, once merely Pluto's shadowy companion, has emerged as a compelling world in its own right, a frozen twin shaped by ancient violence and surprising complexity. It reminds us that even in the furthest reaches of our solar system, there are stories waiting to be uncovered. Stories not just of planets and moons, but of the intricate dance of matter, energy, and time that sculpts every corner of the cosmos. If you enjoyed this deep dive into the hidden wonders of Charon, make sure to subscribe and stay with us on this journey through space. Every world, no matter how distant or dim, has a tale to tell. And we're just getting started. As the light from the distant sun filters faintly through the inky blackness of the Kuiper belt, it strikes Charon with only a whisper of warmth, barely enough to cast shadows, let alone sustain life as we know it. Yet here, at the edge of the solar system, the story of this icy moon continues to captivate scientists and space lovers alike. With every close look, every new data point returned by new horizons, we uncover another layer of a world shaped by ancient forces and unexpected processes. One of the most remarkable aspects of the Pluto-Charon system isn't just the geology or the strange chemistry, it's the relationship between the two bodies themselves. Unlike any other major moon in the solar system, Charon is gravitationally locked not just to its parent, but in a mutual embrace. Pluto always shows the same face to Charon, and Charon always shows the same face to Pluto. They orbit a shared barycenter, a center of mass that lies outside of Pluto's surface, making them truly a binary pair, not simply a planet and its satellite. This synchronized dance has profound implications. Imagine standing on Pluto's surface, gazing into the sky. There, locked in place, Charon would loom larger than any moon in our earthly skies, about 8 times wider than our own moon appears to us. And it wouldn't move. It would hang there, suspended in a fixed spot, never rising or setting, always watching. The same would be true if you stood on Charon. Pluto, with its strange reddish plains and towering ice mountains, would dominate the sky, always in the same place as if time had stopped. This unique arrangement means that the two worlds are tidally locked in a way that's rare in the solar system. Most moons are tidally locked to their planets, but not the other way around. Pluto and Charon, however, are in a state of equilibrium, each pulling on the other until they settled into this cosmic balance. Over the course of millions of years, friction within their interiors slowed their rotations, until finally, their orbits and spin rates matched. Now they turn together, locked forever in a silent, symmetrical spin. This locked orientation may also help explain the distribution of features on their surfaces. For example, the location of the red polar stain on Charon, Mordor Macula, is thought to face Pluto's escaping atmosphere, suggesting a continuous stream of particles falling onto that pole over eons. These particles, when subjected to ultraviolet light from the distant sun, become chemically altered, forming the reddish tholins that give Charon its eerie color in that region. Meanwhile, Pluto's own surface appears to have responded to this relationship as well. Its heart-shaped feature, famously dubbed Tombow Regio, includes a giant basin filled with frozen nitrogen, carbon monoxide, and methane. This basin, informally named Sputnik Planitia, lies almost directly opposite Charon in Pluto's hemisphere. Some scientists believe that the mass of this basin may have actually caused Pluto to reorient itself over time, a process called true polar wander, so that this dense region now faces Charon, optimizing their gravitational alignment. In essence, these two worlds have shaped each other, not just figuratively but literally. Their mutual tug has left permanent imprints in their geology, their surface chemistry, and their orientation in space. And there's something even more fascinating to consider. Pluto and Charon may have formed together in a cataclysmic event, not unlike the one thought to have created Earth's moon. The prevailing theory suggests that long ago, in the early days of the solar system, two large icy bodies collided in the outer solar system. The impact would have been violent, blasting debris into orbit around the larger body, most likely Proto-Pluto. From this wreckage, Charon slowly coalesced, forming a tight orbital bond with its partner. This theory is supported by their similar compositions and densities. Both Pluto and Charon are composed of roughly 50 to 70% rock and 30 to 50% ice. Their densities are nearly identical, suggesting they formed from the same mixture of materials. And Charon's size, about half the diameter of Pluto, makes it far too large to have been captured by Pluto's gravity without such an impact scenario. If this origin theory is correct, then Charon is not simply Pluto's satellite, it's Pluto's sibling, born of the same destructive event, forged from the same materials, destined to orbit together for billions of years. This dual formation echoes the story of Earth and the Moon, another cosmic pair linked by a shared, violent past. But there's another layer to the Charon mystery that continues to intrigue scientists: the possibility of habitability, or at least preconditions for it. While Charon's surface is undeniably frozen, the internal heat generated early in its history from radioactive decay and tidal forces might have created a subsurface ocean of liquid water. In fact, the evidence of surface cracking and tectonic shifts strongly supports the idea that Charon once had such an ocean. Today that ocean may be long gone, frozen solid as Charon cooled over time. But if pockets of warmth remain deep within, insulated by thick layers of rock and ice, then it's possible that small reservoirs of liquid water still exist. And wherever we find liquid water in the universe, we are forced to ask, could life, at least in microbial form, ever have taken root? So far, there's no direct evidence of life or even organic processes on Charon beyond the formation of tholins. But future missions may change that. With the right instruments, a lander or orbiter could analyze the composition of surface materials in detail, drill beneath the icy crust, or detect chemical signatures that hint at prebiotic chemistry. These are questions that can't be answered from a brief flyby. Which brings us to the limitations of our current knowledge. New Horizons was a technological marvel, a once-in-a-generation mission that revolutionized our understanding of the outer solar system. But it was just a flyby, an extraordinary moment, captured in passing. It didn't have time to map the entire surface of Charon, let alone perform long-term studies or investigate the deeper mysteries lying beneath the ice. What we have now are tantalizing clues. Snapshots. A sense of wonder stoked by glimpses into a world that demands further exploration. Scientists have proposed follow-up missions. A Pluto orbiter that could spend years circling the system, deploying landers or atmospheric probes. With modern propulsion systems, ion engines, and nuclear power sources, it's entirely feasible. The real question is whether we'll choose to go back. And perhaps we should. Not just for the science, though there is plenty of that to justify such a journey, but for the story. Because Charon is more than an icy rock at the edge of the sun's influence. It's a symbol of cosmic partnership, of resilience, of the strange and unexpected diversity that defines our solar system. From the moment it was discovered, half lost in Pluto's glow, to the day it stood revealed as a world of canyons, landslides, and ancient ice volcanoes, Charon has surprised us. It's easy to forget here on Earth that most of the solar system remains unexplored. We've only scratched the surface, glimpsed the shadows, mapped the outlines. But the deeper we look, the more we realize that no world is ever truly dead, and no place is truly empty. Even in the farthest reaches of space, far beyond the warmth of the sun, nature finds ways to surprise us. And perhaps that's the ultimate lesson of Pluto and Charon. That every corner of the universe, no matter how remote or overlooked, holds a story worth telling. A mystery waiting to be solved. A secret written in ice and stone, in silence and light.